Next assignment 3. Let V be the finite dimensional vector space over the field F and let dimension of V is equal to n. Then generating set with n elements is a basis for V. This we have to prove. It is given to us that dimension of V is equal to n, and we have to prove that the generating set with n elements is a basis for V. Right? So it is enough to prove that not more than n elements can span V, because if n elements forms the generating set, which means the vector space V is spanned by those n vectors only, right? So we will claim that no subset of V which contains less than n vectors can span V, right? So if suppose V1, V2, V3 up to Vn span V, suppose. So I have to prove that not less than n vectors can span V. Let's suppose that m vectors are spanning V and where m is less than n. Right? Suppose the vectors less than n spans V. So I will reach the contradiction. Okay? Right. Now let B is equal to, let's say again, W1, W2, W3 up to Wn be the basis for V, because dimension of V is n given here, so we have to choose W1 up to Wn. Not choosing, but we have to write the number of bases as n. Now since Wj is belonging to V, any of these Wj belongs to V, and V is a finite dimensional, and here it is given, we have supposed that V1, V2, V3 up to Vm is spanning V. So V1, V2, V3 up to Vm. This is spanning V. And because Wj is the element of V, which means every element of V is a linear combination of these generators. So there exist scalars for that specific Wj, alpha 1j, alpha 2j, so on, such that Wj is equal to, yes, V1 alpha 1j plus V2 alpha 2j plus so on Vm alpha mj, because total number of vectors in the generating set is m. So we have m scalars, right? Let's write this in summation form. I going from 1 to m. So this is alpha ij vi. Oops, I have written the other way. Sorry. Let me write this again. Alpha 1j v1 plus alpha 2j v2, so on, alpha mj vm. Now is it okay? Let me mark this as 1. Now we will prove that these W1, W2, Wn are linearly dependent. Then only we can reach the contradiction. Let's prove that this is linearly dependent. So let C1 W1 plus C2 W2 plus C3 W3, so on, Cn Wn is equal to 0. Then summation j going from 1 to n on Cj Wj is equal to 0. Putting the value of Wj over here. So this is Cj summation I going from 1 to m alpha ij vi. Always remember Cj is working as the number of variables. So this implies taking the summation I first. This is m and this j going from 1 to n, Cj alpha ij and this is vi equal to 0. So these are the set of homogeneous linear equations. So summation j going from 1 to n, I am taking this set of linearly homogeneous equations to be equal to 0. This is equal to 0 now. This is equal to 0. I is going from 1 to m, marking this as 2. This is the system of m homogeneous linear equations in n variables. Remember, Cj is working for variables, and variables are from 1 to n. Therefore, it is written that n variables and m homogeneous equations. Now, since the number of equations is less than number of variables, because we have supposed that m is less than n, right? See, we have supposed v1, v2, v3, vm span v, right? The number of vectors less than n is spanning v. So here number of vectors are m, and this is less than n. So n is number of variables, right? So number of variables is n, and number of equations will be then m. So the system 2 has a non-trivial solution. Whenever the number of variables are greater than the number of equations, then the system is having non-trivial solution, which means the determinant is 0, which means not all C1, C2 up to Cn are 0. So not all these are 0. If these are not 0, not all are 0, which means all the w1, w2, w3 up to wn are linearly dependent. So these are linearly dependent, which means these are not bases of V, because for the basis of V, we must have the vectors to be linearly independent. So this is the contradiction, which is a contradiction because it is given to us that dimension of V is n, so it must have n number of bases. So this is a contradiction, so our supposition was wrong, which means no subset of V which contains less than n vectors can span V. But we have supposed that less than n vectors can span V. So this supposition is wrong, which means no subset of V which contains less than n vectors can span V. Now let's take the generating set. Let's suppose, because now the generating set is having n vectors, right? Let's take one generating set of V, and I'm taking the variable to be u1, u2, u3 up to un. Fine. Now remaining is to prove that this is linearly independent. To prove these to be linearly independent, suppose these are linearly dependent, right? Then there exists I, such I, where I is going from 1 to n, such that ui is a linear combinations of rest of the vectors. Let's choose one ui from here, because as it is, we have supposed, sorry, not from here, from here, because we have written here that u1, u2, un are linearly dependent, which means there must exist one specific ui which is the linear combinations of the remaining vectors. Yes, so this ui is a linear combinations of the remaining vectors u1, u2 up to, because ui has been removed, that is equal to the remaining vectors, so I minus 1, ui plus 1 up to un, right? So therefore, which means, because this ui is a linear combinations of these remaining vectors. So which means u1, u2, this is ui, which means u1, u2, ui minus 1, ui plus 1 up to un. This is a generating set of V, because ui can be written as a linear combinations of these remaining ones, which means these remaining ones are the generating set of V, which is a contradiction, because the generating set of V is containing number of vectors as n. Here the number of vectors are less than n. So this can't be the generating set of V. So this is the contradiction. So our supposition was wrong. These u1, u2, u3, un are then linearly independent only, right? So the generating set with n elements is a basis for V. So we have proved the first condition for the generating set. This is first condition. We claim that no subset of V which contains less than n vectors can span V. First condition for the basis is proved, and then the second condition is also proved. Second one, that is the generating set. These remain the generating then the generators of V are linearly independent. So these two conditions for the basis has been proved. So here the proof ends. Thank you so much. Goodbye.